Hi guys, so welcome to episode 6 of the Year Project Diaries. In the previous episode, we started looking at how, like the middleware aspects of our software, and we started trying to figure out where the nodes are and the number of nodes and the kind of components that are connected to specific nodes in our circuit or the circuit that the user will build, right? So we wrote some very interesting logic. I don't know how else to describe it, but that's what you're seeing on your screen right now. Let me increase the size so that everyone can see that. Like I was saying, we wrote some very interesting logic, and well, I don't know how to describe it, but I'm hoping that you guys can see my screen and then you can see. We've not actually finished it because we've not yet figured out what we are going to do with when it gets a short circuit and this parallel circuit wahala. But then for now, I'm going to like commit this code and would start to draw the voltage source, so that at least when we are doing this middleware stuff and then the simulation backend things, we could have like a complete circuit that we can actually simulate with a source and a resistor. I think those two components can help us simulate, so that we would see if what we are working actually works, if what we are doing actually works. Yes. That being said, I'm going to commit this change. Somehow I forgot to commit my changes last week. That's last week. Yesterday, I mean. All right. So first check git status and yeah, git add, git commit. What I'm going to say, initial logic for finding nodes in circuits. Git status. Yeah, changes committed. I'll push them later. Right now I don't have internet connection. Yeah, don't worry about internet connection. We'll figure that out later. I don't know if my text editor, like the text in the screen, you can actually see, but I feel it's very big because, well, at least it's big on my screen. I don't know for you how you guys are seeing it, but please, if it is too big, if the previous video's size is okay, let me know so that I go back to that, because this is a bit large for me. Thank you. Anyway, yeah. So for the voltage source, basically just go to the components directory, and just like how we created a resistor, I'm going to like basically follow the same steps to create my voltage source component. So over here, I'm going to create a new file for voltage source.py. Yeah, I believe that's how to spell voltage source. Right, and I'm going to open the resistors on at the side, collapse this so that we have more space. So we have voltage source here. This is the resistor code. I know I'm covering somewhere at the top so you guys can see this side, but I believe you guys can see what's underneath it, so that's cool, right? Anyway, so the voltage source is also going to use the same stuff that we are using over here, right? Right. So it's going to inherit from the general component that we created last time. I think I can show you guys that general component. Well, we didn't create. I showed you guys what the general component is all about. It's basically like a structure for our components. That's it. And then they have to have this get terminal positions function that would allow them to actually get the terminals and all of these things. Now, but before we actually like start coding all of this, go back to our architecture, and then we add the voltage source as part of the stuff in here so that everything will be organized. Now I just realized that here I wrote get terminals, but it actually gets terminal positions. That's the name I gave the function here. If you can see, get terminal positions. I mean, it's just a minor change, but I feel it should correlate. Anyway, I'm going to copy this and paste, and here we are going to have our, so this is basically our the voltage source A, right? Voltage source, which is also a graphics item that we would use on the canvas. And it is, yes, we have to like develop the physical appearance. Hopefully today I can actually spell appearance correctly. Physical appearance of the, you know, the voltage source itself. And then it's also have to like, you know, by physical appearance I mean like drawing a cell or a battery. I think I should draw a battery. Well, drawing a battery or like the structure of it. Basically that's it, right? Because all of these other stuff would be taken care of when we inherit from the unique ID's point of view, right? So going back to the code, what we are going to do is to like literally just like inherit from it, right? So from that general, import general component, and we are going to create a class for the voltage source, which we inherit from the general component, and give this class a name, voltage source. I don't know if it's right to call it voltage source, but for now it's fine. What else do we need to do? So I said we are going to be copying the resistor, right? So we define our init function, define under init. Right, it takes in the component count, right? It takes in no parent, returns nothing, and then yeah, that's it. And then just like how we have the geometry specifications, would figure out something. So this is like the major aspects, right? Because how do I say it? This is like the major aspect because we are going to be using the height and width to actually do the drawing, and if we don't get it well, it wouldn't appear well on our canvas, right? Right. I hope you guys get like what I'm trying to see over here. So yes, the geometric specifications, geometry or geometric, whatever, geometry specifications of the components of the voltage source. Now, I don't know if I should draw this one to horizontally, but since I've already drawn the resistor horizontally, I'm going to draw this one to horizontally. So the width will be more than the height, right? So self dot width would be, I think the same size as the resistor is okay, 70. Yeah, it should be okay. And then, I mean, if it's not okay, we would like make it vary, and then we'll figure something out, right? So self dot height should be equal to 20 self dot terminal length can't spell terminal length right is this, and of course the draggability aspects of things too would be set. I said this draggable thing, I think I should actually like move it into the general components because I think all components should be draggable, right? But for now just going to copy and paste this so that I don't have to like waste time typing it, right? Then I have to import this graphics from pyqt6 .qt widget. I hope that's the right place to import it from. Q graphics item imported, and yeah, then we try and draw the components from by defining the paint function. So define paint, right? Yeah, it's obviously going to take in all of this, which it's really not necessary for us, right? But then I'm going to do it anyway. Q painter. I think we can find a Q painter in quick fix. No, there's no quick fix. Anyway, from pyqt6 dot qt core import qpainter. Okay, no, it's not. Okay, I think no, it's not there. Maybe it's in qt GUI, I guess. Qpainter, yeah. I don't know why we're importing this if you're not using it. I mean, so like under normal circumstances, we're just supposed to like let it draw itself, right? But I'm going to return this, right? Like, I mean, remove that, not return it. Define our pen just like how we did it in the resistor components at the right side here. So our pen would be qpen, and we'll have what? I mean, we've not imported qpen, so it doesn't know what qpen is, but it's also here. I just import it here, and our qpen, we specify the color, right? I don't know if I should use blue for this one. I'm just actually right now I'm just doing stuff from qt core import qt, I believe, from pyqt6.qt core import qt. So qt dot was global color dot blue. Just choosing colors actually, like no worries. The size of the pen and the style of the pen. So qt dot pen style dot solid line, of course. And when you create a pen, then you create a painter, right? Sorry, you take it, you basically add a pen to the painter object. So painter equal painter dot set pen, and when you set the pen to a pen that we just created, and then we start to do our math, and then we start to draw. Now it would be nice to actually like have something that I can draw on here. That's why I wanted internet connection, but it seems I don't. So I'm going to use, I think there's a pen tool. I'm going to use this pen tool, and then we'll try and like draw on here on the stuff like here, then later we'll clean it, right? So looking at how our resistor is going to be, sorry, our voltage source is going to be, it's going to be like a line like this. Then maybe the positive side will be on the left side, right? Like this, something like this. That just reminds me, how would you know which side is the positive side and how would you know which side is the negative side? Maybe we can always do it such that is the first terminal, like terminal 1, that would be the positive side, and terminal 2, that would be the negative side. That's also something to have a look at, right? But this is how our voltage source is going to be. And I'm going to change the color here. And then don't forget our width of the whole application. How I'm drawing this, I'm using my trackpad to draw this. That's why I'm very slow, so I'm sorry. But then our width is something like this, and our height is somewhere around here. And of course our terminal length is like this distance. Oh, change the color. Our terminal length is this distance, and then without something left, right? So you realize that this is 15, right? This part is 15. I feel like I'm wasting your time. This is also 15, but the width that we've defined is what we define. The width is 70. The width is 70 and the height is what, 20. Now I want to do it such that I wouldn't have to like use these values themselves. Would write them as expressions, like the points. We'll write them as expressions in terms of the width and height, so that anytime we change the width and height, everything will just adjust to it. Like if you look at how I did the resistor, everything is written as a function of the width, the height, and the terminal length. So like no matter what we do, as long as we don't have to change how we drew it, we just have to change the width and height and the size of the whole thing will change, and then everything would like work. That's the idea that I'm trying to like paint over here. So trying to draw this, trying to draw this is now, should I say, the problem? Right? So if we have the width and the terminal length, we need this point. You see, we are drawing lines, so we need certain points. We need point A. Should I call this point A? Oh, that's a lot. We need point A. We need point B, which is this point, which I can get from how we did it on the resistor. I can get these points, right? But now we need this point, and we also need this point. Then we need this point, and we also need this point, and we need this point. We need this point, this point, and this point. So we're going to be drawing four vertical lines, and the first vertical line would be this, second vertical line this, third one this, and this. So just I'm just going to like draw a better version of this so that we figure out like how to actually do this, right? So the first vertical line that we are going to draw, right, that's what we're going to draw. And this here, I think, would have the points at the top here as, actually I should just write this with the, so I think this point should be the, you see, if I have the body width, I'll come back to that, right? If I have this body width, if I have the width of this body, then I could just separate it into 4 aspects to be able to like get what I want. Because I have this, and I want to draw a line, a long line here. Let me use this. I want to draw a long line here, a short line here, then a long line. Alright, that wouldn't work. Alright, actually that's it. A long line, then another short line. But I want this short line to be here. Which means that if I want the last short line to be here, then this short line should be like 1/3. And this long line should also be like 1/3. So you realize that from here to here, 1/3. From here to here, 1/3. And from here to here, 1/3. So in order to get this, if I have the body width, then this would be the beginning of the body width. I mean, I could just code this out and then you guys will figure it out. But then I'm trying to like try and like let you guys understand what I'm trying to do, because it's weird, you know. So looking at the first blue line over here, that would be the beginning of the body width, and its x would be the length. You see how the canvas, how the item works is such that this point, let me use another color for it. This point, the beginning point of the whole object that we've got here, this point would be 0, 0. So if this is 0, 0, this point would, like the x part of from here to here, the x point over here would be the terminal length for the x-axis, and the y-axis will still be 0. So that's 1 point. So we can get this point, and we can also get this point. Very simply, very simple, very simply, very simple, right? So going back to this over here, I'm saying that for the first vertical line that we are going to draw, we are going to have this point, the first point being terminal length, comma, that's terminal length on the x-axis, and 0 on the y. And this part is going to be same thing, terminal length on the y, sorry, terminal length on the s is constant, but on the y it would be the height, so height of it, right? Then the second line that we are going to draw, actually I think I should move this somewhere else because it seems going to interfere with this we are doing, right? So the second line that we are going to draw, the short line, now this short line too, you see, we could divide this into, you see, it would be a function of the height, right? And if you look at the height, we can divide it into 3. No, we can divide it into 4. And then take from here to here to be that short line. So if you divide the height into 4, means that the x part over here would have to be this terminal length plus whatever distance this is. And remember, we said that this would be the body width, undo. This would be the body width divided by 3. Like we've already decided that it would be a division of 3. So if here is the terminal length, then from here to here would be terminal length plus body width divided by 3, because this whole thing is a body width. So here we're going to have what? The x part being what? Terminal length. Can we just write terminal length as TL or something? Terminal length plus body width, comma. So plus body width divided by 3, then comma. Then the y aspect of it. The y aspect of it, I'm saying that we should divide the height into what? 4 aspects and take just one. So it would be what? Height divided by what? 4 at this point. Then this part, the x wouldn't change because it's a vertical line. So TL plus body width divided by 3. Then there will be a comma, right? And this part, the height rather now become what? Height divided by 4. I mean, that's 1. But then we are going to multiply it by 3. So 3 times of the height divided by 4 would give us from here to here. I mean, 3/4 of the height, right? I hope it's straightforward. I know it's not looking straightforward, but I'm hoping it's okay for us to like understand. We have to do the same thing for the next aspect, right? Oh, right. The next long line. Right, so for the next long line, this would be your terminal length plus 2/3 of the body width, right? So 2 body width divided by 3. The height will still be 0. Sorry, I mean the y-axis would still be 0. I mean corresponding with this. Then this part would be what? The s part will remain constant. Terminal length plus what? 2 body width divided by 3. But the height will just be the normal height that we know. Right. Then we go back to this short line again. Sorry. That doesn't seem short enough. Right. Then go back to this last short line over here. Whose the beginning point would be this part would be what? Terminal length, right? The initial terminal length that we know. Terminal length plus, so if this is 2 times of the body width, then this would be the full body width, right? So plus the body width and the height to be the normal h on 4. And this part, obviously the s will remain the same. TL plus body width, right? And this will be what? The 3h on 4. I think I should also change this to 3h on 4 instead of the bracket. That would be better. Right, so we have something like this. I hope you guys are still with me though. Then the last line here. Let me use another color. I mean, this is the actual terminal, right? So for this terminal, the initial part of it could be the X part could be the initial terminal length. So you see, I think it would be better to start from here. Let me move this up a bit so that it would be easier to like actually look at what I'm doing. So what I'm saying is that there is a terminal here. Oops. So what I'm saying is that there is a terminal here and there is a terminal here, right? So this part would just be, you know, let me zoom in a bit. And the whole thing is a rectangle. Don't forget that. I think I should just use a normal rectangle around it, right? And make it dotted lines. Make this one green or something. Yes. So what I'm saying is that this point, and write in black, this initial point would be the x aspect of this would be just 0 because that's the beginning of it, right? Then the y aspect of it will be half of the, so 1/2 of the height that we have, right? Then this point, the y aspect of it would be the terminal, sorry, the x aspect of it, the horizontal aspect of it would be the terminal length because from here to here is a terminal length. And then the vertical aspect of it will still be what? H on 2. That makes sense, right? So when you go all the way up here, this would be the terminal length plus the body width, because we know that in between here, in between here, the blue aspect here is our body width. So if you know the body width, then we just like add that to the initial terminal length and we get this point. Another way that we could do this, okay, let me finish this. So terminal length, the height is still the same, height on 2, and the ending part over here will just be what? The full width of the thing that we know, the width that we know, right? And then the height will still be what? H on 2, right? I hope this makes sense. But then this point could still at the same time be what? The width that we know minus the terminal length, right? And the height will still be what? H on 2. I don't know if that is making sense, but basically it is this basically what I'm trying to say is that it is this math that we've done over here that we are going to use to draw our horizontally shaped voltage source with all of these points. Hopefully everything works out and we are good to go, right? So they're going to start with the body. And how do we get a body width, right? How do we get a body width in the first place? The body width will basically just be equal to the normal width that we know minus the 2 times of the terminal length. because there is one terminal length and one terminal length here, which means that the body width will just be like the total width that we know minus what the normal terminal length that we know. So body width equals width minus 2 times the terminal length. I'm sorry if this is all math and it got boring. I mean, you could have skipped this part of the video, right? But I hope you enjoyed it. I enjoyed it. Like, this kind of stuff interests me, so I find it interesting. Right, so with this idea, that's good.